Welcome to all here in the session of mathematics. In previous two episodes already we have discussed the concept of vectors and the definition of the vectors. Also we have done some problems related with the vectors carrying 4 marks as well as 6 marks. In today's episode we will do analytical proof, that is the proof by vector method. So let us take the first question. He has given, that is proof by vector method that the two diagonals of any parallelogram bisect each other. Okay, you have to do this proof by vector method. So let us take the first one parallelogram named by ABCD. You have to mention the vertices of the parallelogram represented by the vector A vector, B vector, C vector and D vector respectively. Then if you will take the direction of AB same as the direction of DC, and also we know that the opposite sides are equal. So AB vector can be written as is equal to DC vector. So AB vector means what? B minus A vector, that is B minus A vector is equal to C minus D vector. Why? Since AB vector means position vector of B, that is B, minus position vector of A, that is A. B minus A is equal to C minus D. Now transferring A into RHS, D into LHS, we will get B plus D vector is equal to C plus A vector. Dividing both sides by 2, that is B plus D by 2 is equal to C plus A by 2. Now you see what is B plus D by 2 from the figure. Here B vector plus D vector by 2 means that is the portion vector of the midpoint of the diagonal BD. The position vector of midpoint of diagonal BD is B plus D by 2. Also C plus A by 2 means what? The position vector of midpoint of diagonal SE. Okay, so you will mention here that is the position vector of the midpoint of the diagonal, this one is BD, is equal to the position vector of the midpoint of SC. That means if the position vector of two diagonal, midpoint of two diagonal are coincide, that means the two diagonals are intersecting each other at the midpoints. So therefore the two diagonals intersecting each other at their midpoints. That means what? The two diagonals bisecting each other. The two diagonals are bisecting each other. Okay? Do you follow or not? Again I am repeating. Suppose the four vertices of the parallelogram ABCD represented by the vector A vector, B vector, C vector and D vector respectively. Okay. Now AB is equal to DC. If you will take the direction same of AB and DC, then opposite sides of the parallelogram are equal. So therefore AB vector is equal to DC vector. That is B minus A is equal to B minus A is equal to C minus D. Then B plus D is equal to C plus A. Then dividing both sides by 2. B plus D by 2 is equal to C plus A by 2. That is the midpoint of two diagonal are coincide. That means they are intersecting each other at the midpoint. So therefore they are bisecting. Okay. Make it a note. Now I'll go to the next problem. Now we read the next question. Very interesting one. You see, the line segment joining the midpoints of two sides of any triangle is parallel and half of the third side. You have to prove these questions in vector method. Okay, so first you will draw one triangle, that is the triangle ABC, whose vertices are represented by the vector A vector, this one is B vector and this one is C vector. Let the midpoint of the any two sides, suppose midpoint of AB is D and midpoint of AC is E. Then the position vector of midpoint of AB, that is position vector of D, is nothing but the A vector plus B vector by 2, isn't it? Again, position vector of midpoint of E is A vector plus C vector, A vector plus C vector by 2. Okay, it will join this one. Now you will find DE. D vector is equal to how much? That is position vector of E minus position vector of D. Position vector of E, that is OE vector, minus position vector of D means OD vector. This is nothing but the OE vector. OE vector means position vector of E, that is A vector plus C vector by 2 minus A vector plus B vector by 2. That is nothing but the LCM is 2. A vector plus C vector minus A vector minus B vector. A vector cancel. Then we have left to C vector minus B vector by 2. And this is nothing but the half of C vector minus B vector. Okay. C vector minus B vector is nothing but the BC vector, isn't it? So half of BC vector. Which one? This vector is D vector. So D vector. So DE vector is equal to scalar multiple. Half is one of the scalar multiple of BC vector. When one vector is expressed scalar multiple of other, then the two vectors are parallel to each other. So from this we conclude that D vector is parallel to BC vector. Since D vector is scalar multiple of BC vector, that's why D vector is parallel to BC vector. Again, if we will take magnitude, both side, D vector magnitude of that is equal to magnitude of half is nothing half and magnitude of BC vector. So magnitude of D vector is half of the magnitude of BC vector. That is D is half of BC, also D parallel to BC. Likewise you can prove. And for the fair note, you can go through the description box. Okay. Now I'll go to the next problem. Okay. Now we read the next questions. You have to prove by vector method the line joining the midpoints of the consecutive sides of a quadrilateral is a parallelogram. Okay. First we will draw one quadrilateral, that is any type of quadrilateral. Suppose ABCD is a quadrilateral. See, A, B, C, D. Now you will join the midpoints of consecutive sides in order. You will join likewise. So let this name by AB, midpoint of AB is E, this one is F, this one is G, this one is H. And the vector represented by the vertices of the quadrilateral ABCD, let it be A vector, this one is B vector, this one is C vector, this one is D vector. Now the position vector of E, that is OE vector, is equal to how much? A vector plus B vector by 2, since this one is the midpoint. That's why position vector is A vector plus B vector by 2. Now position vector of F, OF vector, is nothing but the B vector plus C vector by 2. B plus C by 2, and position vector of G, that is OG vector, is equal to C plus D by 2, and position vector of H, that is OH vector, is equal to A plus D by 2. A plus D vector by 2. Now we have to prove EFGH is a parallelogram. Now what about the EF vector? So you can find EF vector, that is position vector of F minus E, that is OF minus OE. OF is equal to how much? B vector plus C vector by 2 minus OF minus OE, A vector plus B vector by 2. That is taking LCM, B vector plus C vector minus A vector minus B vector by 2. So B vector cancel, C vector minus A vector by 2. Now this one just we have found EF vector. Now we will find HG vector. What about HG vector? That is position vector of G, OG vector minus OH vector. Position vector of G minus position vector of H. OG is C vector plus D vector by 2 minus OH, that is A vector plus D vector by 2. This is nothing but the taking LCM 2. So C plus D minus A minus D. Okay. So D cancel. Okay. That is C vector minus A vector by 2. So you see here HG vector is equal to C vector minus A vector by 2, and also EF vector is equal to C vector minus A vector by 2. Hence you can write EF vector is equal to HG vector. That means 1 into HG vector. So one vector is scalar multiple of other. That means EF vector is parallel to HG vector, and also if you will take magnitude of both the sides, then EF vector magnitude is equal to HG vector. So in this way you can prove. Now we read the next questions. That is, in any triangle ABC, the point P being on the side BC, if PQ is the resultant of the vector AP vector, PB vector and PC vector, then prove that ABQC is a parallelogram. Again you read the questions. Any triangle ABC, suppose the triangle is here, that is ABC is a triangle ABC, and P is any point on the side BC. Suppose here P is a point on the side BC, and in such a way that Q is another point, such that you have to prove ABQC is a parallelogram. Suppose first you will draw the parallelogram ABQC, and PQ is the resultant vector of AP. AP means this one, and PB means this one, and PC means this one. PC, AP, PB, PC, resultant of AP, PB, PC is equal to PQ. That means what? PQ vector is equal to AP vector plus PB vector plus PC vector. This one is given. PQ vector is resultant of AP vector, PB vector and PC vector. That means what? AP vector plus PB vector plus PC vector is equal to PQ vector. From this, PQ vector minus PC vector is equal to how much? AP vector plus PB vector. You see, AP vector plus PB vector is equal to how much? AB vector. So this one can be replaced by AB vector. So you have to prove ABQC is a parallelogram. So simply AB vector is equal to CQ vector. If you will prove, then parallel, opposite sides parallel and their magnitude equal, that means parallelogram. So here AB vector means this one should be CQ vector. Why? You see, PQ vector minus PC vector is equal to, we have written CQ vector. See, PQ vector is equal to PC plus CQ, whether this one happening or not. PC plus CQ, PC plus CQ is equal to PQ, is not it? PC plus CQ, PC plus CQ, PC plus CQ is equal to PQ by the triangle addition rule. So since this one happened, PQ is equal to PC plus CQ, that implies PQ minus PC is equal to CQ. Okay. So that's why you will write this one is the reason. PQ minus PC is equal to CQ. So PQ minus PC should be replaced by CQ. CQ is equal to AB, that means CQ is parallel to AB. Okay, CQ is parallel to AB. CQ is parallel to AB. Likewise, you can prove AC parallel to BQ, or you can write modulus, taking modulus, CQ modulus is equal to AB modulus, then ABQC is a parallelogram, since opposite sides are parallel and equal. So that's all for the today's session. In the next episode, we will discuss the second exercise of this vector algebra of 12th class. Until then, goodbye. Thank you.